Okay, so you have went through the food web, and I even threw you a curveball. We introduced a an extra species into this food web, and we have looked at the addition of a new species into a food web, and we've even called it something. We called it an invasive species. They are not good because my phone just texted me again. Oh, and it's beeping. I'm going to put it on silent. How unprofessional of me. Let's get the show rolling. Okay, I've got no time to talk about board games with my best friends. Why would I talk about fun things when we're talking about more fun things like stink bugs? Uh, One time I had a stink bug problem. I used to live in an apartment complex called Autumn Lakes, and my apartment was really close to like the wooded areas, right? And all the apartments in Autumn Lakes have this like little shed area where you can like put your bowling balls and your luggage. So springtime comes around, right? And it starts getting warm. And my wife's like, let's go bowling. Because that's what she likes to do. Um, and so I get my bowling ball because she got me one for Christmas one year for my birthday or something. Um, and she opens up her bag with her shoes and her ball, and just flying out of each hole of the three that you put in the ball, the three holes of the ball, just stink bugs just flying out. Oh my goodness, it was awful. And then we get to the bowling alley, and she takes out her shoes, and there's just stink bugs everywhere. Oh my, they are awful. Stink bugs are gross. Smush them and don't look back. They're an awful species. Anyway, we talked about how in person, we should have talked about this in person. If we didn't, tell me and we'll talk about it. How if invasive species take resources from other organisms, then the population of these guys skyrockets. But if nothing is eating the stink bug in this situation, then you've got a problem, right? Because you've got the population of the stink bug skyrocketing. But then these guys right here, the green fly, which eats berries, butterfly, which eats berries, titmouse, grasshopper, mouse, and rabbit, all of them start to lose resources, right? That's a problem. Invasive species are bad because they take resources away. And notice there's no arrows pointing away from, I'll draw a line. There's no arrows going away from the stink bug to the buzzard. So nothing is controlling their population. So they keep growing and growing and growing, and there's all these resources for them, and they just flood everything. Bad news. Very bad news. We'll talk more about that later. But anyway, let's go back. So we've been talking about energy being transferred through an ecosystem, which is good, right? We've got energy moving, but how energy moves, it kind of follows a pattern, okay? If you follow the transfer of energy, and what I mean by that is like if you follow how much something eats, right? All of that isn't reserved inside of the organism. So for example, you go to Evil Czech, my favorite restaurant. I love Evil Czech. And you get a chicken and waffle burger, and that thing weighs 1 pound. Okay, and you eat all 1 pound of it. If you eat all 1 pound of it, by the time that is done fully digesting, how much weight have you gained? Did you gain 1 pound? Well, no. You've taken the moisture from that burger and you peed it out, and you took the solid from that burger and you used a lot of the energy from it, but you kind of pooped out the rest, and your body used it for energy, right? So your body used up that energy and released it back into the atmosphere like as heat. Like your body's like breaking it down in your cells, and you're like exhaling it back into the atmosphere as carbon dioxide, which we'll get much more into detail later. So of that pound, how much do you think you keep? Like in your body, like stored as skin or muscle or fat? Do you know? Let's take a look at this example. I've got a cow, I've got grass, which is eaten by the cow, and then I got me and my wife and my little baby who eats the cow in the form of a delicious burger. If a cow ate 10 pounds of grass, by the time it's done digesting it, it will only keep approximately 1 pound of it. The other 9 pounds get released back into the atmosphere as some form of heat, energy, mass, something. Okay, so some of it will leave as it'll leave as poop, right? Some of it will leave as pee. Some of it will be released as CO2 and water back into the atmosphere. And of all of that, we're talking about 0.9 pounds. So this cow, or I'm sorry, not 0.9 pounds, that's a mistake. This cow will keep 1 pound and it will release 9 pounds back into the atmosphere from one of those ways. Okay. So we kind of we didn't waste 9 pounds, but it took 10 pounds for it to keep one. Imagine 10 pounds of grass. That's a lot of space. 10 pounds of grass is a lot of space for one cow, for one burger. Well, I mean, you're going to make more burgers than just one from this cow, but 10 pounds of grass is a lot of space. Imagine how much space that is, and then translate that into growing other plants. You could make so much more vegetables for you to eat than just giving all of this to cows, right? I think we're going to do a little bit of research later on just how much land is used to shove corn down these cows' throats their whole life. So, according to this, we've got 90% that is released from the organism, and we've got 10%, approximately, it's never perfect, that is kept in the organism. So if I ate this 1 pound burger, how much would I keep within me? What's 10% of a pound? That would be 0.1 pound. And how much do I get rid of? Total 0.9 from all the ways I showed you over here that I'd rather not talk about, or anything that has to do with it, like the squatty potty or bidets, anything like that. I'm not going to talk about on camera. I will never talk about the squatty potty or any sort of, toilet accessory. We call this the 10% rule. 10% rule claims that as you move up an energy pyramid like this right here, 10% of the energy is stored in the organism and 90% is released back into the atmosphere. So I've got that right here. Approximately 10%, sometimes more, sometimes less, based on, starts with an M, metabolism. You've heard of that word before. So if you have a higher metabolism, you might get rid of more. If you have a slower metabolism, you might get rid of less, right? That makes sense. 10% of the energy is stored within the organism, while 90% leaves the organism in the form of heat, waste, energy, something. Okay? All right. Let's stop there, but I want to just touch upon what we're going to be talking about next time. If you looked at how all of these organisms from this food web interact with each other over time, now we're not just talking about one specific incident. We're talking about two organisms interacting over the course of a very long time. So let's talk about like mouse or rabbit. We'll talk about rabbit population versus fox population. You are able to record patterns of populations over time that analyze the populations based on how they interact with each other. Okay, so you can see the prey population over time. This might be like 100 years. This might be like the year 1900, and this might be the year 2000. Okay, and you can observe the fluctuation in population numbers over time. So you see how the prey, which would be the rabbit, going up and down over time, and how this wolf, was it a wolf or a fox? I forget. Oh, that's a fox. Yeah. How the predator population also, it's like a pattern. It's like a cycle. But we're going to look at that next time. But your homework in groups. Okay, I'm going to give you time to work in groups together, so don't freak out on me. Okay, you're going to be working in groups in your modules. You can find this activity. It is called Energy Transfer in Living Organisms. Your assignment is questions 1 through 5 and 8 through 13. We will come back to 6 and 7 at a later date once we get a little bit deeper into ecology. Honors, begin researching the term cellular respiration. That's a big deal. 10 minutes. Don't go nuts on me, okay? Try to find out what the mechanism does, what it means. We're all going to be looking at this together eventually. Answer the following question, Honors. How does cellular respiration have anything to do with eating food and releasing energy? What does that mean? How do they... Don't just Google that question either, because I made it up. So odds are you're not going to find a direct answer. So yeah, I will see you guys live either right after this video or maybe the following day. So peace. See you later. Good job. Congrats. Your first day or your second day. I don't know what we're on right now, but we did it. Good job. See ya.